Oh my goodness, you guys, I am so excited to start our Calc 2 journey together. Woo, I'm so excited. So the first thing we get to look at is in section 7.1, inverse functions. We're actually going to spend the majority of our time on this one talking about the algebra kind of behind this and getting ourselves set up. We won't get into calculus until the very end of this section, but it's good to get the groundwork right. Previous information into the current lesson. That's always a good thing to take a look at. All right. My handwriting, those of you that have not had me in class before, leaves a little bit to be desired. Sometimes I get to writing too fast and it gets a little sloppy. So I'll always say what I'm writing. And if you ever have a question, always feel free to ask in class. Super happy to answer any of those questions. All right. So without further ado, let's rock the socks off of this thing. So the first thing we're going to be talking about are inverse functions. All right. So in order to have an inverse function, the function has to be 1-to-1, which that is just a symbol for it. It's a 1-1. Let me make that to where it doesn't look like an H, which means 1 to 1, and pass the horizontal line test. Horizontal line test. So in order to have an inverse function, that's what you're looking for there. So it has to pass that horizontal line test in order to be able to pull that off. All right. Okay, so we know an inverse function just because we know from previously that they swap out the x's and y's. And the other things that we know is the fact in order for this to be 1-to-1, that is a special category of a function. So original function here, let's just put a little extra notes. To get a function just by itself, we know that the x's can't repeat. Right? That's what we automatically know whenever I'm talking about a function. Then, in order to get even more specific with the 1-to-1, then I know that the x's and the y's can't repeat. So in also order to have just a function in general, I know it has to pass the vertical line test. But we're told that these are already functions to begin with, so I don't have to worry about determining if this is a function or not. I'm just determining if it is a specific type of function, which is going to give me an inverse. Okay? All right. So we already know it's a function. Check. That's down. We're good. Then, is it specifically, in order to have an inverse function, the function has to be 1-to-1 and pass that horizontal line test. All right. Let's take a look here at example 1. Let me go back to blue. So we are going to determine the largest possible intervals. Determine the largest possible intervals which the function is 1-to-1. Function is 1-to-1. Okay, that's what we want to know. And here is our function. So I've got it on here. I'm just going to bring it on up. Wasn't sure what kind of space I would have, so I kept it small to begin with. Ta-da! There you are, you little beauty. Now remember, in order for this to be 1-to-1, the x's or the y's can't repeat, right? So I have to look at this and say, all right, I have to pass the horizontal line test. Where in my graph does it switch over? Right? So I'm going along, and then there's a point where it no longer passes that horizontal line test. What's happening at those places? Yeah, exactly. You get a max or a min, right? Check it out. This one's already color-coded, so it's kind of doing the job for us. I'm coming along, everything's dandy. I come up here to this maximum, and as soon as I go past that and start going down, that's when I start failing my horizontal line test, right? Yeah, so when I'm looking at these, I'm looking for that maximum and minimum value, those points that we have. So if I want to look for my possible intervals, and I'm not saying how these connect to each other, I want to take them independently. independent intervals. All right, intervals. So my first possible interval there is going to go from negative infinity to -1. Now, if I'm going to go for the largest possible, should this be a parenthesis or a bracket? Good, bracket, right? Because I want to count this -1. This, independent of itself, is going to be this entire interval because I want the largest possible. So I'm not up to -1. I want to count that -1. All right, now, again, with the maximum and minimums, I'm trucking along here, and then I start going back up again, and that's when I fail. So I can only come down here from this -1 to what? 0. Gosh, you guys are so good. Oh, I just did it automatically, and I should have said something to you. So -1 to 0, and again, we're going for largest possible, so that's our bracket. So this is our second interval that we're looking at. Okay, what's our third? You're seeing the pattern here, right? Yep, 0 to 1, brackets. And then our last one, yeah. 1 to infinity. Now, you don't put a bracket on infinity, obviously, right? Because it's infinity. So if you were to write this out in your homework, what are the largest possible intervals? You'll just put commas between these because you're making a list. This is a list of those largest possible intervals. All right? Okay. So in your homework, let me get to the next page. In your homework, you're not always given the graph of what it is. So for instance, we have this 7.1.22. So in your homework, you're also going to have, like we talked about in class, this is the chapter, this is the section, and then this is the homework problem number. So this is the code that's on your homework in My Math Lab. Okay, so we're looking for the largest possible set of points on which the following function has an inverse. On which the following function has an inverse. Remember how we just talked about that handwriting? Holy bajoli. Let me try this again. Ooh-wee. That said following function. You may have been able to read it, but I'm going to try it out just a little bit better. Okay, where the following function has an inverse. Now remember, in order to have an inverse, it has to be 1 to 1 and pass the horizontal line test, right? So previously on this question, we said, where is the function 1 to 1? Where does it have an inverse? Same deal. Same deal, right? Same concept. Okay, so they just give you f of x is equal to x squared minus 2x plus 8. No graph. What is this? I know, dust the cobwebs off. It's been a while, but you got this. What is this? What kind of graph is this? Yes, right? It's a parabola. So I know a parabola either looks like this U or it looks like this hill. Same concept applies till you get to that vertex in this instance where it's a minimum, and then you go on. You come up here to the top, which is that vertex, and then you go on. So these are broken in half. So that's the point, right? I want to get that vertex. Right. So in My Math Lab, I think it tells you to complete the square. Don't go completing the square. That's the hint they give you. That's the worst possible hint in the world. For this one, you just want to you can find your vertex. Don't you remember? X is equal to negative b over 2a. And I'm only concerned about the x coordinate. That's all I'm concerned about. Whenever I'm talking about intervals, it's always with those x values. So I have a negative of -2, which is 2, over 2 times a, which is 1. So 1 is that value. The largest possible intervals, I'm going to go from negative infinity to 1. And it's not a union, it's a comma because I'm making a list. Then I'm going to go from 1 to infinity. Good. What's another way? And you may have already said it, and obviously I can't hear you, but What is another way? Yeah, we know calculus. We've all been through Calc 1. Anytime you want to find a maximum or a minimum, that's your first derivative. Ah. So another way to pull this off, not complete the doggone square, another way to pull this off is to take this derivative. My derivative here is going to be the 2x minus 2. I set the derivative equal to 0. That gives me that horizontal tangent, right? That horizontal tangent is what I'm looking for the maximum and minimum. Add 2 to both sides, divide by 2, and lo and behold, we come up with the exact same thing. There's the one I'm looking for. There's the one I'm looking for. We're good. All right? I don't care how you do that. It's however you want to do that, but I would not recommend completing the square, which is the recommendation they give you. They're just taking something, and the purpose of what they're saying is just they're taking this problem as a quadratic and they're putting it into vertex form. The goal is to get the vertex. Like, oh, this will be easy to do. No. I would totally not do that. All right? Okay. So largest possible set in which the following function has an inverse. You're just trying to figure out those x values so that you can work with that. Where is this going to be 1 to 1? Okay. Awesome.